Welcome to NAB 2024. I'm here with Post Perspective at the MTI film booth, and we're going to show off some interesting tools with our Cortex product. Cortex is a classic utility tool that's been used in post from everything from dailies to finishing with IMF packaging and DCP packaging, using a typical user interface where people would manipulate the front end, go in and a lot of clicking. What we're trying to do today is introduce automation intelligence using our MTai prompt tool to actually drive our Cortex product. So Edwin's going to launch our MTai prompt tool, as you can see on the screen. And what we're going to do is, could you go ahead and just create a QC of an IMF for us to show how that works? So now Edwin's going to pull up our prompt tool. What he needs to do is just browse to our library and find the content that he wants to QC. And he can just drag and drop onto the Cortex icon our IMF package, and then from there, simply type /QC and hit enter. So now we've seen that Cortex is open and a project is open. It's validated already to IMF. And in the lower left-hand corner, there's some numbers it's starting to analyze. So let's not wait around while it analyzes. Let's use the MTI tool to continue the automation. So Edwin, can you go ahead and create an IMF for us? So now, similar to what we did, he would just back out of his MTI tool to the IMF workflow. He'd select the project that he wants to launch it into. And then again, he can drag his OCN material, the video OV, the audio stems, the left track and right track of audio, the 5.1 sound, and then drag it onto the system and again, say, create an IMF. But what type of IMF do I want to create? There's several pre-built templates from Netflix, from Sony, from Disney, the BBC, Sky, DPP. So with that, let's use the Netflix Dolby Vision HDR, because we're now supporting Dolby Vision 5.0. And again, he just launches that command and Cortex will open in the background and immediately create a composition for you where you have your video track, your metadata and audio there, and he can start to spot check that against the metadata and go ahead and next assign the language track. So in an IMF, you could typically add supplementals and subtitles. He's going to assign English language to this and then go ahead and just simply kick off a render. So while that's off rendering in the background, I'm going to ask him now to create a dailies workflow, all using the same MTI prompt tool. So he'll step back from his IMF workflow, select a dailies workflow that might include creating Avid Medium, ProRes, and H.264, and then just drag his entire project of the original camera media, the OCN files, along with the audio from set, along with any CDL provided data from the DIT and the ALE form, and then just say sync and launch that through the prompt tool. And what it does, again, opens Cortex, goes ahead and creates a project. The video falls into the video bin and audio into the audio bin, and it starts to synchronize and bring together the audio and video through timecode match, audio waveform, and slate detection. And then from there, while that's off creating its deliverables, we're going to go back to the project we initially kicked off, which was the QC of an IMF. So now it's validated, but it's also created a bunch of data that we call the graphs, where I have my video levels, my bit rate, any matte detection that might be for blanking, loudness, as well as you could also run a dead pixel detection. The other thing it automatically does for you through this automation process is generate the reports. So you can go out to his desktop to find a CSV file or a PDF where it'll show you a much more comprehensive, detailed report of those code values, of the IRE values, of the nits min max, of the actual fall CLL, or in this case, the max CLL, and the frame and the pixel that was causing the brightness at that point. It will display the color gamut, it'll display any kind of matte blanking errors, as well as the loudness and audio analysis, and any discrepancies that may exceed those boundary points. All that was done from just a single drag and drop command using the QC tool. So why don't we go back and take a look at that IMF? Is that fully rendered now? So it has rendered and it's prompted Cortex to bring it back into the project. So you see the original composition, and now underneath the tree was built with the rendered result. It says it's locked because now it's rendered, and you can go off, spot check it, make sure it's correct, and then from there, drop it back into the prompt tool to further QC it, or run it right from the tool with the QA tool. So the last thing I'd like to show is, we've been moving along here pretty fast, but also go back and look at the results of our dailies creation and see how those are done. So it looks like those are done now. You see that the elements have been sunk together, the color has been applied from the EDL. All the operator needs to do now is go through and QC that again, put eyes on to make sure that the sync is correct, and make sure that is actually what the metadata says it should be, and then verifies also, on set they're moving fast, sometimes there's errors, mislates, and that we can go QC that, generate those reports, and deliver it off. On the up top, you can see I can get a preview. I can look at my Avid media with burn-ins, or maybe an H.264 that I'll send to Pix, or a ProRes version that may be for marketing. All rendered simultaneously within the tool in the background through just a simple prompt command to say sync. So that's a little sneak peek into what we're doing with version 6.0. One other thing I'd like to show off that's kind of exciting is using our AI tools to do frame rate conversion. You saw our frame gen tool within DRS. Now within inside of Cortex, we have MTai. So I can take a clip, let's say it's a 24 frames per second clip that I want to generate at 60 frames per second to smooth out any sort of motion. So I have a clip here. It's about 23 seconds long, about 860 plus frames, and it's playing down here. These M&Ms will fall out of the sky onto this tray, and you see these leaves move, and this clip's a nice, aesthetic clip. But what I'd like to do is generate it at 60 frames. So instead of it now going from 24 to 60 and playing 2.5 times faster, it maintains the same code base of this 23-second long clip, but it is now going to be at 60 FPS. So we'll play that down for you, and you can take a look at how it plays. Now, the nice thing is we're not just duplicating frames and interpolating them as you might see in other tools. This is using generative AI to synthesize new frames. So I'd ask you to stop here and just step through the frames, and you can see each one is a unique frame, not a duplicate with some interpolation. And if you play it down in real time, you see how smooth and fluid it is. So another just simple use case example of something like this would be, say, going from 30 frames down to 24. We're doing some remastering, taking television show, and we want to do like an inverse TK and take it to 24. Traditional approach is to just drop frames. So here's this clip, this woman's running. You can feel sort of the staccato pulsing of the motion. Here it is with our MTai generation. It feels like a nicely shot slow-mo clip. Let's look at that just one more time. You can feel the sort of pulsing of those drop frames, even though you get the desired effect of 24 frames. But now with MTI, you get this nice smooth motion. So one last example I'd like to show in this is an aerial shot. Typically some of that stuttering comes on a digital camera when you're panning. And if you look at the background hillside, you can see as the camera moves, it feels out of sync with the foreground elements and the horses running. Now with MTai, you get this nice smooth motion as if it was acquired at 24 frames. And definitely look at the back and how now it's nice and smooth and continuous. So we'll look at that one more time just to visualize that. The horses look like they're beating more than galloping. And that stepping, is quite apparent. Now the horses look like they're in nice fluid motion at 60 FPS, and that panning feels much more organic. So the other feature that we have inside of Cortex, which is unique in the industry, is dead pixel detection. Digital cameras suffer those artifacts, with exposure to light and getting pixels that eventually fade away. And there's nothing worse than taking your show to Netflix when you're wrapped and having it rejected because there's a dead pixel. So we have a tool that can actually detect those dead pixels and correct them. Here's a shot from a movie. We're going to import a whole clip. We're going to break it up using the EDL that will now know the camera roll information, so that if I make a correction on a clip that's associated with camera A, it can know to propagate any other shots in that clip that are associated with that camera. So Edwin's imported an EDL, and he's now analyzing it. Moves very quickly, multiple frames per second you can see will be done with this analysis, and it'll then define several areas, what we call candidates for dead pixels. So it's about to finish up the analysis, and you'll see in the screen area here now, these dead pixels appear. And Edwin has the ability to determine if it's really, how severe are those dead pixels? How long do they persist? In this case, if he goes to the maximum severity, you'll see that there was really only one dead pixel that was, sticking there the whole time. But you can go through this, make sure there's no what we call false positives. I might have a shirt with a button and the light reflecting off of it. I'm not moving, it appears to be a dead pixel, but then I move and all of a sudden the light's obscured and blocked and it's no longer determined. So we're gonna select one of those dead pixels just to show you how this works. So here's an egregious example of a red dead pixel in this woman's hair, and as the camera's moving through, you can see that dead pixel traveling through. What we don't want to do is correct for that and then create a different artifact and now have a hole in her hair, right? So the process is to be able to preview that candidate and be able to toggle it on and off. So I could say, there it is, and go through and do these spot checks and make sure I'm not creating any artifacting. And then at that point, if it's correct, I can accept it and move to the next event. And it's smart enough to know that the XY position of that camera, if this woman appears later in the shot, or I should say that camera appears later in the shot, most likely will have those same dead pixels. It'll correct across the board. So it's all about automation intelligence. It's an acronym that rhymes with AI, but it's not AI. It's about being smart in your workflows and moving them forward. Where we apply AI is in use cases that really have a need, like frame rate conversion, like replacing a jump cut or replacing a slug in a particular piece of film that's been broken and put back together. This is where we can actually use the true AI technology in a generative form, but then also use automation intelligence to make things fast and efficient. So thank you for looking at our interview today of Cortex at the MTI Film booth. Thank you, Post Perspective.